Your first question is, when a piece of polythene is rubbed with wool, a charge of -2 into 10 to the power -7 is developed on the polythene. What is the amount of mass which is transferred to polythene? So according to question, we have polythene which is rubbed with wool, and after rubbing it is found that polythene is developing a charge of -2 into 10 to the power -7 coulombs. Polythene gaining this negative charge means that polythene has excess of electrons transferred from your wool to polythene. Obviously, since each electrons they carry mass, polythene now must be gaining mass. So the question was, what is the amount of mass transferred to polythene? In order to find out how much mass is being transferred to polythene, we have to count, or we have to know the number of electrons being transferred to polythene. To calculate the number of electrons, we use our quantization rule, which is Q equals to Ne, where Q is given to be -2 into 10 to the power -7 coulombs, and we do not know the number of electrons, and E is your electronic charge. So when we rewrite it to calculate N, we write Q by E, 2 into 10 to the power -7 coulombs by 1.6 into 10 to the power -19 coulombs, and we get 1.25 into 10 to the power 12 as the number of electrons gained by your polythene. Now, mass of every electron is 9.1 into 10 to the power -31 kgs. So if 2 electrons are transferred, we have to multiply it by 2. Now since we have calculated that the number of electrons transferred is so much, so we are multiplying these two and we get the total amount of mass transferred by those many electrons. So we have simply multiplied the number of electrons with mass of each electrons. And after calculating, we get so much mass. Okay, let's go to the next question. The question reads, 10 to the power 12 alpha particles, helium nucleus, per second falls on a neutral sphere. We must calculate the time in which the sphere gets a charge of 2 microcoulombs. Let's have a representation of this. We have a neutral sphere, and according to question, the alpha particles are falling on this neutral sphere. 10 to the power 12 number of alpha particles per second. And after some time, you will see that the total charge gained by this neutral sphere will become 2 microcoulombs. The question is, how much time it takes for this neutral sphere to become or to have a charge of 2 microcoulombs. Now, first of all, we must understand what are alpha particles. If you see this helium atom, we have 2 protons and 2 electrons. Alpha particle is nothing but your helium nucleus, which means we do not have the electron here, we do not have the electron here. Alpha particle is simply a system of 2 protons. Hence, the charge on alpha particles must be 2 times the charge on each proton, that is plus twice E. Now, charge on each alpha particle is plus twice E. Number of alpha particles falling on the neutral sphere per second is 10 to the power 12. Therefore, we can say the charge falling or the gain by the neutral sphere per second must be twice E times 10 to the power 12. You can see this is the number of alpha particles, and this is nothing but charge carried by each alpha particle. If we are to write the amount of charge gained by the neutral sphere in t seconds, we must simply multiply this formula by t. Because if you remember, this was a charge gained by the neutral sphere per second. If it is for 2 seconds, we have to multiply this by 2. If it is for 3 seconds, we have to multiply it by 3. Because every second, more and more alpha particles are falling. Clearly, this is the amount of charge gained by the neutral sphere in t seconds, not in 1 second. Now, if I write charge gained by the neutral sphere is 2 microcoulombs, I can equate these two and say twice E plus twice E into 10 to the power 12 T equals twice microcoulombs. What this equation means now is that in a time of t seconds, the charge gain or the total charge gain by the neutral sphere is 2 microcoulombs. So we simply have to find this time in which the total charge gained by the neutral sphere will become 2 microcoulombs. So we have written here 2 microcoulombs, which is 2 into 10 to the power -6, and we have to divide by twice E into 10 to the power 12. When we solve this, we are going to get the answer in seconds, which is your 6.25 seconds. Okay, next question is, what is meant by additive nature of electric charge? We know electric charge is a scalar quantity, and just like other scalar quantities, we can add them like algebraic numbers. Like if a body has a charge of plus 2 coulombs, it also has a charge of minus 2 coulombs, plus 5 coulombs, plus 10 coulombs. The total charge in this body will be simply the algebraic sum of all these charges. Hence, this property we call it additive nature of electric charge. Next question, what does Q1 plus Q2 equal to 0 signify? Here we can write Q1 plus Q2 equal to 0, and then we can write Q1 is equal to minus of Q2. It simply means that charge Q1 and Q2 are both equal in magnitude, but they have opposite nature because there is a negative sign. Next, what are the various methods of charging? What we have already discussed is only friction, but I'll show you that there are other methods by which we can charge a body. First is of course your friction, second is your induction, and last is your conduction. Next question is, what is charging by induction? Suppose we have a neutral body and we bring a body which is already charged. Let's say a plus charge. As I bring this body near to this neutral body, you will see the electrons present in this neutral body are going to be pulled closer to your positive charges because of electric force, and the other side of this body will try to gain or will gain a positive charge. We can say that this portion of your neutral body is charged, and we can say even this part of your neutral body is charged. In this process, notice we have not touched the charged body with the neutral body, and this is what we call as induction. So if a charged body is brought near, not in contact but just brought near to a neutral body, the charged body will attract opposite charge and repel similar charge present in the neutral body. That means we are talking about protons and electrons. As a result, one side of the neutral body becomes negatively charged while the other becomes positively charged. This process is what is known as induction. Notice this body where induction takes place is not gaining or losing charge, it's just separating the charges. Hence we have written inducing body neither gains nor loses charge. Or even you can see this body here which was bringing the induction, which was developing the charge in this body, is not gaining charge or losing charge. The nature of the induced charge is always opposite to that of inducing charge. That means this inducing body will always develop a charge near to it which will be opposite. This is positive, that's why it is inducing a charge of negative in the neutral body. What is charging by conduction? When we have a body which is already charged and we bring it to a neutral body and actually touch them, you will notice that the positive charges from the charged body gets transferred to your neutral body, and the charge in your charged body decreases. But you can see the neutral body has now some charge. So this process of charging of two bodies by actual contact between the two bodies is what is known as conduction. Here the charged body loses some of its charge, and that charge lost is equal to the charge gained by the uncharged body. Obviously, if the charged body has lost 2 coulombs of charge, then this neutral body must have gained those 2 coulombs of charge. The next problem is your Ncert problem exercise 1.11. The question reads, a polythene piece rubbed with wool is found to have a negative charge of 3 into 10 to the power minus 7 coulombs. We have to estimate the number of electrons transferred from which to which. We have to even say from where to where it is getting transferred. And we also have to write if there is any transfer of mass. So let's quickly have a representation for that. So we have here polythene and we have wool. If you read properly, polythene is found to have a charge of 3 into 10 to the power minus 7, and they have mentioned it is negative. Obviously, you can say the electrons are being transferred from wool to polythene because of which the polythene is gaining a negative charge. It has excess of electrons. So we have written the charge gained by your polythene. Then we have used the quantization rule, which is Q equal to minus N times C. This minus is up to you, you want to use, you can use, or without the minus also you can work here. We simply write N equals to Q by E and put the value of your Q, which is 3 into 10 to the power minus 7, divided by your E, which is your 1.6, 10 to the power minus 19. On simplification, we are going to get around 2 into 10 to the power 12, which is nothing but the number of electrons transferred from wool to polythene. Now the second question is there a transfer of mass? The answer is yes, because each electron has mass. Therefore, when the electrons they go from wool to polythene, mass is also transferred from wool to polythene, and the polythene will become a bit heavier now. How much heavier we can calculate by writing mass of each electron times the number of electrons that are transferred. So we have written the mass of each electron and we have written the number of electrons that are transferred. On simplifying, we get 1.82 into 10 to the power minus 18 kg, and of course which is quite small. This question is from NCERT again, exercise 1.4. Explain the meaning of the statement electric charge of a body is quantized. You have already seen this in your previous video. Quantization means that charge observed on any body is always going to be some integral multiple of your elementary charge. So we simply have written that, where n is your whole number. Now the next question, there is something to discuss here. Why can one ignore quantization of charge while dealing with macroscopic or large scale charges? To understand this question, let's say we have a body that is charged. Now since it is a macroscopic body, the amount of charge gained by this will be quite large, and the value of each your elementary charge, which is your plus or minus 1.6 into 10 to the power minus 19 coulombs, this number is going to be quite small. So I'll repeat again, the charge gained by this macroscopic object will be very, very large compared to your electric charge. Hence we will not observe your quantization rule if you are dealing with macroscopic object, because macroscopic objects have very large amount of charge, whereas your electronic charge or the charge on each individual electron is quite small. Hence quantization of charge can be ignored.